Example 2C. Make frequency histogram using the guidelines in the front on the front of the page. So generally, what you will need to do is you need to figure out how many bins to use and how wide each bin is going to be, or how many intervals. So first, you need to find your range. Your range is the maximum number minus the minimum number. For us, that is 9.5 minus 1.8. Which gives us a range of 7.7. Next, we need the number of data points that we have, which right now is 47. And we need to take the square root of 47 and then round it. So the square root of 47 is 6.855. Call that 6.855 for a second, but that rounds up to 7 bins. So we're going to have 7 groupings. And we take our range of 7.7 over our 7, and 1.1 is the bin width. So before, where we had the width of a half in here, or 1 in the earlier one, now we're going to use 1.1 so that we can get 7 roughly equal groups. To speed this up a little bit, I have pre-made a graph. Messed up just a little bit up here, but that's okay. So you can start your x-axis for sales tax rate at your minimum number if you want to. I put a little squiggly here to say that, hey, I'm not actually starting here at 0, I'm starting at 1.8. And then from 1.8 to 2.9, I just added 1.1, added 1.1 again to get to 4.0, added again, until I got all the way out to 10.6. I had to use the 10.6 because of kind of how some of these transitional numbers go. Like the 6.2 is where we have to draw a line. So what I did was I went back through my list again, stat edit. So anything between 1.8 and 2.9, I start counting. There's only one of those, but again, the 6.2s, I believe. So everything before the 6.2, the 6.0, the 5.8, the other 5.8, all 10 of those go in there. But I have two of those 6.2s, and so the 6.2s actually belong in this category out here. So that's why we go up to 18 on that one. Same thing happened. Our biggest value was actually 9.5, so the 9.5 belongs in its own special category on the right. So if you ever run into problems like that, I think there might have been maybe some 7.3s in there as well. Yeah, 7.3 also belongs in the side on the right. But each of our bins is 1.1 long. Again, you can choose how many boxes you count by. Our frequency our y-axis still has to start at 0, but we're counting up. And now we can start looking at part D and seeing, does this look roughly at anything kind of like what we have there? And yeah, that's not super duper balanced. I mean, we're kind of higher on the right side and we're starting to pull more on the left side. So it looks like we are still skewed left. Which means our median is the best measure of center. And if we look back for part E to compare our results for all 3 of them, so when our bin width was a half, we were skewed left. When our bin width was 1.1, we were skewed left. And when our bin width was 1, we were skewed left. So all 3 histograms are skewed left. but their heights vary. When you change the bin width. So the overall shape should stay the same, even if, sorry, the shape of the distribution should stay roughly the same, even if we're messing a little bit with the heights and stretching it left and right. Again, because all three are skewed left, the median is still the best measure of center for every version of this data. And again, if you really wanted to state what that means for us in practical terms, stat calc 1 variable stats on L1, our median value is 7. So if I had to just pick one number for the sales tax rate across all 50 states, I would say it's probably close to 7%, but you might get a little bit higher or a little bit lower, depending on what state you're in. And that was histograms.